Imagine every single atom of oxygen on Earth vanishing right now. Not for a year, not for a day, just for exactly 5 seconds. Most of us can hold our breath for 5 seconds without breaking a sweat, so you might assume humanity would easily survive a quick pause in the air supply. But before you even realize you need to take a breath, the sky above you goes completely black. Oxygen particles in the atmosphere scatter sunlight to create the blue sky. Take them away, and broad daylight instantly plunges into midnight. Biological suffocation is the absolute least of your worries. The physical world around you is about to react so violently that you won't even have the luxury of missing your next breath. The exact moment the oxygen disappears, every internal combustion engine instantly dies. Fire simply cannot exist without oxygen. Millions of cars cruising down highways freeze in their lanes, and thousands of commercial airplanes flying at 35,000 feet lose thrust, dropping instantly into a silent, powerless freefall. At the exact same time, the sudden loss of atmospheric oxygen causes a 21% drop in global air pressure. The massive atmospheric shock causes the inner ear of every living creature on Earth to burst instantly. Then comes the catastrophic collapse of our infrastructure. Every concrete building, massive hydroelectric dam, and towering skyscraper simply disintegrates. It seems like a physical impossibility. Why would a brief pause in an invisible, breathable gas cause the heaviest, strongest structures humanity has ever engineered to dissolve into thin air? To answer that, we have to look past the collapsing skylines and zoom deep into the microscopic structure of a single block of concrete. We tend to view concrete as a brute force material, a dense, hardened mixture of crushed stone, water, and cement powder. This molecular lattice shows the active chemical web inside concrete. Oxygen atoms are the essential binding agents here, locking elements together. This oxygen-based matrix creates the immense compressive strength needed to hold up skyscrapers and withstand thousands of tons of force. We interact with these monolithic structures every single day, walking across bridges and working in high-rises, completely taking their massive structural integrity for granted. Concrete is a delicate chemical equation, holding its shape, locked together by the air we breathe. But when that 5-second window hits, that equation breaks. The moment oxygen disappears, the chemical bonds holding the concrete's components together cease to exist. The material doesn't fracture or crack under the immense weight of the building above it. It loses its structural integrity at the atomic level, reverting instantly to unbound dust. This chart highlights how this chemical failure scales far beyond man-made structures. If you analyze the Earth's crust, you find a massive composition of 45% oxygen. Removing that binder causes the literal bedrock beneath our feet to crumble, triggering a catastrophic worldwide freefall of the planet's solid surface. The removal of a single atomic binder from the periodic table equates to the instantaneous physical failure of the entire planet. When those 5 seconds are over, the oxygen rushes back into the atmosphere, and the pitch-black sky returns to a familiar bright blue. The baseline physical properties of the world stabilize. Engines could spark again, and atmospheric pressure equalizes. But that brief interruption is entirely fatal. The complex chemical bonds inside the concrete and the bedrock cannot spontaneously reassemble themselves from the dust. A mere 5-second glitch in our planet's baseline chemistry is enough to permanently erase human civilization. It forces us to view oxygen differently, looking past its biological role in keeping our lungs functioning. It is the invisible, physical glue that literally holds our constructed and natural environments together. This thought experiment exposes the extreme fragility of all the modern materials we treat as permanent and indestructible. Human survival relies on a razor-thin margin of safety, deeply and precariously intertwined with the fragile chemistry of the cosmos.